Okay, we also have a section on absolute value equations and inequalities. So let's remember what an absolute value does. It measures distance, which means it doesn't do anything to a positive number, but it does do things to negative numbers. So when you have the absolute value of something like x equals 3, then x could be 3 or negative 3 because both of them are 3 away from 0. Which means, in general, your absolute value equations will break into two different situations. One where your equation is equal to the positive, and one where your equation is equal to the same value but negative. To do absolute value inequalities, we're going to have to deal with the same kind of situation where we break it up into two pieces. Just remember, if we're getting rid of a negative or adding in a negative to a number, that's going to change the direction of our inequality because multiplying or dividing by a negative number changes the directions. Now, there are a few special cases as well. Remember that an absolute value can never be less than a negative, and an absolute value will always be greater than or equal to a negative if you have either of those situations. If you have the absolute value equation is equal to 0, there's only going to happen one place when the equation is equal to 0, because if you have a positive 0 and a negative 0, they're the same thing. Same for like less than or equal to 0, that's everywhere. Greater than or equal to 0, absolute value again is greater than or equal to 0 everywhere. So let's look at how this works. So the absolute value of 5 minus 3x equals 3. So remember, that means it's either 3 or negative 3. So let's look at our possibilities. Either 5 minus 3x is equal to 3, to get rid of the absolute values and nothing happens, or 5 minus 3x is equal to negative 3. And from here, you'll just solve your equation, whatever kind of equation it is. So move the 5, negative 3x equals negative 2, negative 3x equals negative 8, divide by negative 3 on both parts. So x is 2/3, or x is 8/3. So two possible solutions, and of course you can always plug them back in to make sure they work. 3 times 2/3 is 2, 5 minus 2 is 3, and the absolute value of 3 is 3, so that works. 8/3 times 3 is 8, so 5 minus 8 is negative 3, and of course the absolute value of negative 3 is also still 3. If instead you have an absolute value equal to another absolute value, you have the same thing where we have a positive and negative here, so it's either x plus 1 equals 1 minus 3x with nothing going on, or x plus 1 equals negative 1 minus 3x. Just like we put the negative in front of the 3, the negative goes in front of the algebraic expression, and it'll distribute to everything. So I still solve for x here, add the 3x, subtract 1, we get 4x equals 0, which means x equals 0. In this case, we have x plus 1 is equal to 3x minus 1, negative 2x equals negative 2, divide by negative 2 to get x equals 1. And again, we can plug it in. When we plug in x equals 0, we get 1 equals 1, which is true. The absolute value of 1 equals the absolute value of 1. When we plug in 1, we get the absolute value of 2 equals the absolute value of negative 2. And of course, that negative 2 will become a positive 2, so that's also true as well. The third situation is if your absolute value isn't alone, you should get it alone first. So the absolute value of 8 minus x equals negative 5. Now, this is one of the situations where you may be tempted to break it apart and set it equal to negative 5 and positive 5. But remember, the absolute value is a distance, and it's either 0 or a positive number. It can't be negative. So the moment you have an absolute value lined up against a negative, you can say no solution. Because it can never be a negative. So how does this change with inequalities? Let's say you have the absolute value of 4x minus 2 is less than 2. That means 4x minus 2 is either less than 2 or 4x minus 2 is greater than negative 2. And actually, less thans are really and all of these should be and, because we're sandwiched, right? An absolute value being less than 2 means the equation is really sandwiched between -2 and 2. So generally, the less thans become and situations. The greater thans will become or, because it'll be 2 intervals, whereas the less than is usually only 1 interval. Okay, so when is 4x minus 2 less than 2? When we add 2, 4x is less than 4, x is less than 1. When is 4x minus 2 greater than -2? Add the 2, you get 4x is greater than 0, x is greater than 0. So when x is less than 1 and x is greater than 0, so that's all the numbers between 0 and 1, so we can represent that as an interval, 0 to 1. If you decide to do less thans all in one kind of equation like this, that also works, because if I had added 2, you get 0 is less than 4x is less than 4, and when you divide by 4, you get 0 is less than x is less than 1. This only works for the less thans though, so you have to keep that in mind, but either way you end up with that same answer. Okay, so let's look at this next one as well. 5/3 minus 1/2 x is greater than 2/9. When you have a greater than, instead of and, it becomes or. So we get 5/3 minus 1/2 x is greater than 2/9, or 5/3 minus 1/2 x is less than -2/9. Can't technically be both of those at the same time, which is why the or is helpful. From here, you'll solve fractions, and you'll have 2 intervals when you're done. And it will be the union of both of those intervals as potential solutions. And we'll look at some more of these on the next page. So just like the equations for absolute values, one thing we know is that the absolute value is always greater than or equal to 0. So if it gives you an interval, says this absolute value is greater than or equal to -12, when you see a negative here, the absolute value is always bigger than a negative, and it's never smaller. So in this case, it's automatically -infinity to infinity, because you know any absolute value is always going to be bigger than -12. Absolute value of 5x plus 2 minus 2 is less than 3. Add the 2. Absolute value of 5x plus 2 is less than 5. So again, when you're having a less than equation, you can kind of create a 3-part equation. -5 is less than 5x plus 2 is less than 5. Subtract 2. -7 is less than or equal to 5x is less than or equal to 3, or less than 3. Divide by 5. You get -7/5 is less than x is less than 3/5. You can turn that into an interval, from -7/5 to 3/5. And lastly, what do we know about absolute values? They're always greater than or equal to 0. So when you get an absolute value that's less than or equal to 0, the only time that this can be true is when the absolute value of 3x plus 2 equals 0, which means 3x plus 2 equals 0. So 3x is -2, which means x is -2/3. So you can get a single solution. It's rare, but it does happen. And that is all for 8.3.